Hello ladies and gentlemen, and welcome to our lesson today. Today we're going to be doing some greatest common factor stuff. We're just going to be doing a couple more examples for people who, either watched the long video and need a little more, or if you didn't watch the long video and you're just feeling brave and feel like, the class lecture was enough and you just want some more examples, that's awesome. So, quick reminder, greatest common factor, we're trying to find what all of these terms have in common. Like I said in the last video, the first thing that I would do is I'd look for x's, because without doing any math, I can just look and see if they have x's in common and I can pull one out. Unfortunately, in this one, they do not have any x's in common, so these x terms will just remain the same no matter what. I could actually, if I really wanted to, I could already just put down this x cubed and this x squared, and then, well, I don't know what that is. It doesn't have anything, right? So now, because the x's are taken care of, I'm going to look at the coefficients, and I'm going to see what each of these share. These ones are all pretty small numbers, so I can do their factor trees real fast, and I'm actually ran out of room, so I'm going to do 3. It's just 1 and 3. 9 has 1, 9, 3 and 3, 1, 15, 3, and 5. Now, if you guys can't do factor trees that fast, that's totally fine. I've had a lot of practice at this. So, the number that all trees have and the greatest number that the trees all share is 3. So that means that I can pull out a 3 here in front. And just like in the other video, we said that we're going to now divide all of these terms by what we just pulled out. So we said that this x cubed and this x squared is going to stay. That's still true. We're just doing 3 divided by 3 now. That gives us 1x cubed. We're doing 9 divided by 3. Gives us 3x squared. And then 15 divided by 3 is 5. So in this example, we only needed to pull out a number, no x's. That's awesome. So now let's do a different example. Now this one, we're going to have to pull out some x's without spoiling it, but maybe I just did spoil it. Let's go 2x to the third plus 14x squared. So, like I said, without doing any math, you can look at your x terms and know how many you have to pull out. You know that this term has 4 x's. If I wanted to write it out, I could. 4 x's. We know that this term has 3 x's. This term has 2 of them. So without doing any math, I could just draw and circle what all of these share, right? You don't need to know any math to be able to do that. If I just showed you a group of 4 x's, 3 x's, and 2 x's, and I said, what do all these things have in common? You'd probably say x's, and I'd say you're right, but then I'd say, how many x's do they share? Well, 2, 2, and 2. So that means what we're going to pull out, the thing that all of these have in common, is an x squared. Now, to fill in our parentheses, we're going to divide all these terms by an x squared. So x to the 4 divided by x to the 2, we have some x's that cancel, we get x squared. 2x to the 3 divided by x to the 2, we have a couple x's that cancel there, we have plus 2x. And then right here we have 14x squared divided by x squared, just leaves us with 14. That one, on this problem, we only had to pull out x's. Some of them you'll only need to pull out numbers like the last one, some of them you'll only need to pull out x's, some of them you'll need to pull out both, like this next one we're going to do. Let's say we have 4x, let's go cubed, plus, let's see, let's go 20x squared, plus 36. Yeah, 36 is a good one. X. All right, so like I said, no math required. We look at our x's, we figure out what we can pull out. In this one, I'm not going to write them out, but I know that all of them have at least one x. That means that I can for sure pull out an x. Now I'm going to look at the numbers, see what I can pull out. In this one, I could do factor trees if I really wanted, but the way that I would do this, I'd look at them and I'd say, they're all even. I can pull out a 2. Well, let's do that. Just like in the other video, I pulled out a 2 and an x. So that means we're dividing by 2. Well, let's do this. 4 divided by 2 is 2. X cubed divided by x, x squared. Plus 20 divided by 2 gives us 10. And then x squared divided by x gives us x. 36 divided by 2, 18. X divided by x gives us 1, so we can just leave that invisible. Now, is this done factoring? I hope you're shaking your head. If this was a Dora episode, I hope you're shaking your head no at your computer screen, at your phone screen, whatever it is you're looking at. because each of these terms are still even. That means we can still pull out another 2. So I'm going to pull out another 2. I'm going to leave our 2x, and we're going to multiply it at the end. And so now I'm going to divide each of these terms by what we just pulled out. So not 2x, because that was our first step. So we pulled out a 2x. We divided each of these by 2x to give us this. Now we're pulling out a 2. We're going to divide each of these by 2 to give us our new parenthesis filler. So 2 divided by 2 is 1. We're left with an x squared. 5 divided by 2 is 10. That leaves us with a 5x. And then 18 divided by 2 is 9. So now if we were to multiply these together, we'd know that all together we pulled out a 4x. So the correct way that you'd want to write this on your homework or on a test or whatever you were doing would be 4x times x squared plus 5x plus 9. Now, another way that you could do this if you wanted to. Doing it this way is perfectly fine. It takes one extra step than this way I'm about to show you, because we did 2 steps here. We pulled out a 2x and then we pulled out a 2. So the way that I would do this, I look at our lowest number, this leading coefficient here, 4, and I just think to myself, I wonder if this 4 can go into 20. Well, I know that 4 does go into 20. And then I look at this 4 and I go, does 36 go, or does 4 go into 36? Sure enough, it does, 9 times. So if you guys see this, you can just go ahead and pull out this 4 at the very beginning. Now, you might think, Mr. McGill, why'd you look at this 4? The reason I look at this 4 is because it is the smallest of the 3 terms. So if you have a small number when you're trying to pull out a greatest common factor, say our coefficient is 2 or 3 or 4 or 5, look at that number, look at the rest of your terms, and see if those terms are divisible by your small number. That's just a tip. It's just a little trick that I've picked up. You guys don't have to do that. You can definitely do it this way, where you pull out the 2x and then the additional 2. Not a problem. So now we're going to do a couple difference of squares. I went over this pretty in depth in the long video. If you're unsure how to identify a difference of squares, I went on a little bit of a rant in that longer video, so I would encourage you to go there. So let's do a difference of squares of x to the 4th plus 4. Well, I hope you watched that long video, or if you didn't, you know that I can't do a difference of squares for this, because it is called the difference of squares. And what we have here is a sum of squares. This does not help us. If we tried to break this up into x squared plus 2 and x squared minus 2, if we said that this was equal to this, then we're saying that this is equal to that, which is not true. Trust me, this is bad. Don't do that. If there's not that subtraction there, we can't difference of squares. I was trying to trick you guys. Don't do it. Don't fall for it. Okay, so for real though, no more tricks. Let's do x to the 8th minus 9. How would we difference of squares this? Well, like I said in our last video, both of our terms need to be perfect squares. In this term they are. They're separated by a subtraction sign. I know that we're ready to go for this difference of squares. The first thing I'm going to do is take the square root of my first term, x to the 8th. Well, the square root of x to the 8th is x to the 4th. That's because x to the 4th times x to the 4th is equal to x to the 8th. And remember, square root is trying to find what we can multiply by itself to get what's in here. And that is an 8. I know I ran out of room. So that's our first term. So when I do our parentheses, we know that we're going to get 2 binomials here. We know that the square root of our first term is the first term in both of our binomials. So now we look at our second term. We take the square root of our second term. The square root of 9 is 3. If you don't believe me, plug it in your calculator. So that's the second term in both of our binomials. And so now the important part, plus and minus. We need one of each. Okay, there you go. And like I said in the last video, you can flip-flop these. You could have this be your plus and this be your minus. Don't erase with your fingers. There you go. At the end of all my videos, I have a nice little green pointer finger because I always erase with it. Don't do it. I promise you'll regret it. There you go. So x to the 8th minus 9, the difference of squares, if we were to factor it, would look just like this. Woo. We're going to do one more, and then you guys can be on your way. What if I had, do I want to do a tough one for you guys? Okay, let's do it. So let's go x to the 32nd minus, let's do some quick math in my head, 175. Oh no. Well, let me tell you something. This is to the even power, so it is a perfect square. And you don't have to believe me, but this is also a perfect square. The ones that you guys will do, numbers will not be this big. I don't expect you to know this, but for this example, I'm just trying to show off my mental math skills. Most of you probably aren't going to watch this video anyway. If you do give me a hard time about this, I'll know that you care. Anyway, so the square root of our first term, x to the 32nd. The square root of x to the 32nd is x to the 16th. Again, that is because x to the 16th times x to the 16th. If I were to draw it all out, that's 16 x's, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 times all of that. This is the times dot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's 32 x's. So x to the 16th times x to the 16th is x to the 32nd. Our square root of x to the 32nd is x to the 16th. There you go. So that is the first term in our binomials. Now, the square root of 175. I never expect you guys to know this in your head. If you plug it in your calculator, it's 15. I promise. Unless my brain is wrong, which it could be. Let me know. Anyway, 15, 175. There you go. The square root of our second term is the second term in both of our binomials. And then we've remembered our plus and minus, and we have successfully done a difference of squares factoring for this guy, x to the 32nd minus 175. There you go, guys. There's the short video. I hope you enjoyed it. Have a wonderful day. I will see you guys in class, and have a good one.